Subscribe to Amcode and ring the notification bell to get the latest content.
Okay, so far we have just learned about all the data engineering aspect of Apache Spark, but here there is more capability to Apache Spark, which has high level API like the machine learning library as well as the graph processing using the graphics library. So in this lecture we are going to go over the MLlib library, which is provided by Apache Spark, which gives us the capability to run the machine learning algorithms on top of your data and get the hidden meaning out of it. So without wasting any time, let's get into it. Okay, so the first question you may ask is, what really is a machine learning? So basically machine learning is nothing but a procedure for extracting the hidden patterns from your data. So it uses the statistic, the linear algebra as well as the numerical optimization techniques to get the hidden patterns out of your structured data as well as the semi-structured data. So there are different types of machine learning, which includes the supervised learning, semi-supervised learning, then we have the unsupervised learning as well as the reinforcement learning. So in this we are going to discuss all about the supervised learning, and also we'll touch base on the unsupervised learning and what are the different use cases this particular machine learning techniques have. So first, let's start with the supervised machine learning. So in this supervised machine learning, your data will consist of a set of input records as well as the labels. So you'll be assigning the labels upfront for your data, which is nothing but your training data set, and then the end goal is to predict the output label based on the input data. So this is what the supervised machine learning is, but the output could be discrete or continuous, and on the basis of that there comes the two major types of supervised machine learning. The first one is the classification and the second one is the regression machine learning. So let's talk about them in detail and what are the differences between these two. So let's talk about the classification algorithm here. So in the classification problem, we aim to separate the inputs into the discrete set of classes or the labels. So with the binary classification, which is the first type of classification, we have the two discrete label you want to predict, such as in this figure, as you can see, either it is a dog or not a dog. So it's a complete different animal. So based on this, it will give us the two outputs. But with the multi-classes, which is also known as multinomial classification, there can be three or more discrete labels. So here, as you can see, if we have like the data set of the pictures of dogs, then it can predict which type of dog or which breed of dog it is. So this is just an example to show you what is the difference between this binary classification as well as the multi-class classification. So these are used for predicting the input labels. So whatever the input labels you have put in your records, on basis of that it will generate the output for the final data set. But there are some cases where classification will not be the good choice. So for that, let's talk about the regression model now. So let's shift our focus to the next machine learning model, which is unsupervised, which is regression. So in regression problem, the value that you have to predict would be a continuous number but not a label. So we have seen in the classification that it is generating a specific label, so by which we have predicted the dog breeds as well as identified if that picture is of a dog in our classification model. But in regression, it's not some label, it is generating a specific number. So for use cases like in this example, here we have to build a model to predict the daily ice cream sales given the temperature that a current day has. So basically this model can predict the value which is not even there in the data set and in the input label. So this is how it works. So let's say your model predicted the value of $77.67, but that value couldn't be present in the input labels or maybe input values that you have provided. So as you can see, our training data set could have multiple values for a certain temperature that day, but it doesn't work like only the values that are present in the input data will come as an output. It can be anything, and it totally depends on all the calculation that works under the hood of a regression analysis. So let's talk about some of the machine learning algorithms that you can use to implement either the regression or the classification or maybe both. So let's talk about that now. So as you can see, for supervised machine learning algorithms especially, because we are not that much focused on unsupervised machine learning, but let's touch base on that as well. But for supervised machine learning, here is a list of ML algorithms which are present in Apache MLlib library with a node as whether they can be used for regression, classification, or maybe both. So these are the many most popular algorithms which are available, which is linear regression. So as you can see in the name as suggests, it is used for regression. But in logistic regression, even though it has the regression in its name, it's well suited for the classification model where we have to predict some label. And if we have like different many popular algorithm like the decision tree is very popular nowadays, as well as the gradient boost trees, random forest, and the native Bayes. So among these four, we have the decision tree, gradient boosted tree, and the random forest can work with either the regression or classification or both. So the naive Bayes is work only for classification, as well as the SVMs which are also used for classification purpose. So let's talk about unsupervised machine learning as well, to just get you a better understanding of what is supervised, what is unsupervised, and what is the difference between them. Okay, so let's shift our focus to the unsupervised learning. So basically, as we have seen in the supervised machine learning, we should be having a labeled data as an input to the algorithm. But obtaining that labeled data is pretty expensive and cumbersome operation. And if you're dealing with big data, you might face some challenges on the performance as well. So instead of predicting a label, unsupervised machine learning will help you better understand the structure of your data. So let's say if you have a graph database and you have all sorts of connectivity in your graph database, so you can use unsupervised machine learning to split all this data and all these node into some different clusters, so that it could be go as an input to further procedure of maybe a fraud detection system. So if you have a fraud detection system, it can identify the suspicious cluster from your data using different algorithms which is unsupervised. So there are a few which are available in the market, which is k-means algorithm, to split your data into different cluster as per the structure of your data as well as the input parameters which is considered. So in unsupervised machine learning, it can be used for outlier detection, and as I already mentioned that it is used as a pre-processing step for the supervised machine learning. So as you can see, we got the original unclustered data. So we don't know the structure of our data, but when we apply the unsupervised learning, it has splitted that data into three major clusters. So if you have such kind of data, you can use k-means unsupervised learning algorithm to cluster your data to get the hidden patterns out of it. And also you can use this cluster as an input to your further supervised machine learning approaches. So now let's discuss about why we should learn the Spark machine learning. There are several tools that are out there which can implement these machine learning algorithms on your data. So why we should learn Apache Spark MLlib library in the first place? So as we have already discussed that Spark is nothing but a unified analytics engine which is so powerful and scalable, which provides the ecosystem for different tasks like for your data ingestion purposes, feature engineering, data processing framework, as well as the model training and the deployment for your organization. So using the Spark ML will be the right choice because you don't have to worry about integrating all the different tools to implement machine learning. You can use the unified platform which is Apache Spark and use their all high level APIs, which will give you the capability to work with the batch data using the RDD and data frame API, as well as you can work with the real-time data using the Spark streaming application, as well as it can give us the capability to work with graph data using the GraphX library. And also we have the MLlib library which is present to work with the machine learning algorithms. So it will provide you the unified system and you don't need to have to worry about scaling all these tools. Some tools might be scalable, some tools might not be scalable, but here if you use Spark, we already know that Spark is pretty powerful due to its in-memory computation as well as the storage efficiency and the fast processing of the data and its huge scalability and fault tolerance. So you don't have to worry about making your system scalable, highly available as well as fault tolerant. So with the Spark ML, data scientists can use one ecosystem only for their data preparation as well as the model building without needing to downsample your data to fit in a single machine, because as you already know, Spark is a parallel processing framework working in parallel on several nodes across the cluster. So that will give you the capability to work with big data and also apply machine learning on top of them. So that's why Spark Machine Learning is a great choice for every data engineers and data scientists out there. So now, without wasting any time, let's build our first machine learning pipeline to predict the price of the hotels using the Airbnb data. So let's discuss about the data set, and then we will go over all the operations that implement using the MLlib library.
So that's it for today. I'll see you in the next lecture.